we shall introduce the limit of sine and cosine functions. But before we go into solving the limits of sine and cosine functions, we will review how we are evaluating sine and cosine functions or circular functions in general. Theorem 1.9, limit of sine and cosine functions. For any real number a, the limit of sine of x as x approaches a is equal to sine of a, and the limit of cosine of x as x approaches a is cosine of a. So this one looks easy because all you have to do is just directly evaluate your sine and cosine functions when x is equal to a. And why is this so? Again, this one comes from your existence of limit theorem. If the one-sided limits are equal, they are equal to a real number L, then the limit of your function exists as x approaches a and it is equal to L. And we can see that visibly from the graph. Let's say, for example, this one. This is the graph of your f of x is equal to sine of x. When x approaches any real number a, let's say, for example, pi. Okay, look at this. So when x approaches pi from the left, okay, x approaches pi from the left, the value of your function approaches sine of pi, which is 0. In the same way, when x approaches pi from the right, this is how you write it, pi from the right, your function approaches the value of sine of pi, which is again equal to 0. In general, this is how we evaluate the limit of sine and cosine functions. So the limit of sine of f of x as x approaches a is equal to sine of the limit of f of x as x approaches a. And it is the same for the cosine function. So before we go into evaluating limits or finding limits, let us review. Well, how do you evaluate circular functions? We begin from the wrapping function. So imagine any real number t. So for any real number t, you can look at it as the length of a line segment whose length is t. And what you can do is you can wrap that line segment whose length is t around our unit circle. The unit circle is a circle in standard position, and its radius is equal to 1. So we shall wrap our line segment with length t around our unit circle. The initial point will be this one. Okay, and then that arc, that line segment, it will produce an arc around our circle. And this arc has a terminal point. This arc has a terminal point with coordinates xy. And guess what? What is cosine of t? So this is t. This is the length of our arc. So what is cosine of t? This is cosine of t. The first coordinate of the terminal point of your arc, that is cosine of t. The second coordinate of the terminal point of your arc is sine of t. What is tangent of t? Tangent of t is the ratio of the second coordinate, sine of t, to the first coordinate of that point. So it's going to be y over x. I know you had some difficulty evaluating circular functions. It is possible that your teachers gave you a very big table. You feel somewhat compelled to memorize that table. You don't have to do that. This is what you remember. What you will remember are the special angles. 0, pi over 6, pi over 4, pi over 3, pi over 2. These are arcs. Arcs in our unit circle, and these have terminal points. These are the terminal points of your arc. So when it is 0, this is the terminal point. When our arc, or when t is equal to pi over 6, this is the terminal point. So in fact, this is the only table that you must remember when you are evaluating circular functions. Why is that so? Why is that so? Because the first coordinate of this point is your cosine. The second coordinate of this point is your sine. The ratio of the second coordinate to the first coordinate is your tangent. That's all. So this is the only table that you must remember. Okay, so let us find what is sine of pi over 3. So you will go to pi over 3 and you will look for the second coordinate of the terminal point. It is square root of 3 over 2. What is tangent of pi over 6? You go to pi over 6 and you understand tangent of pi over 6 to be the ratio of 1/2 to square root of 3 over 2. And this is equal to 1/2 times 2 divided by square root of 3. 2 divided by 2 is 1. You are left with 1 over square root of 3. And when you rationalize this, this is square root of 3 over 3. Now, how about this? Second of pi over 2. Well, you understood second pi over 2 to be the reciprocal of your cosine function. So you will look for cosine of pi over 2. Cosine of pi over 2 is the first coordinate of the terminal point. And so this is going to be 1 over 0, which means this is undefined. So second of pi over 2 does not exist, or it is undefined. Okay, so let us now level up. Let us level up. Let us evaluate sine of 4 pi over 3. Can you still recall the steps to be done to evaluate this function? Well, this is what you do first. You will trace t, 4 pi over 3. You will trace an arc around our unit circle whose length is 4 pi over 3. Okay, starting from the initial point, 4 pi over 3. So 4 pi over 3 will bring us to the third quadrant. 4 pi over 3 will bring us to the third quadrant. So this part is 3 pi over 3. And then you will add an extra pi over 3 to get here. And here, you are now at 4 pi over 3. Okay, so what does this mean? So this means that this one, your reference angle here is pi over 3. So what you will do is sine of 4 pi over 3 is equal to, okay, you will use the reference angle sine of pi over 3, and then you will affix the appropriate sign. Is it negative or positive? Well, in the third quadrant, your sine function is negative. So sine of 4 pi over 3 is equal to negative sine of pi over 3. So you will go to pi over 3. This is sine of pi over 3, but you will affix the negative sign. How about this one? Tangent of 5 pi over 6. So 5 pi over 6 is a little short than pi because 6 pi over 6 is pi. 5 pi over 6 will bring us to the second quadrant. We are almost reaching pi. So this is 5 pi over 6. And what is our reference angle? The reference angle is this one. That is pi over 6. So how do you evaluate tangent of 5 pi over 6? So you will use the reference angle. Okay, tangent of pi over 6. You will affix the appropriate sign in the second quadrant, and in the second quadrant, tangent is negative. And so you will look at pi over 6. So 1/2 over square root of 3 over 2, and we found it to be equal to square root of 3 over 3, and then you must affix the appropriate sign. It's negative. How about secant of 10 times pi? Where is 10 times pi? Okay, so again, you will produce an arc whose length is 10 pi. So 1 revolution is 2 pi. That's 2 pi. So to get to 10 pi, you will make 5 revolutions. And this is where you will end. So that is your terminal point. So the terminal point is, it's 1, 0. That is your reference point. You will use this. Okay? You will use this. So secant of 10 pi. Okay? So our reference angle here is 0. Secant of 0. Second, this is the reciprocal of your cosine function. So what is secant of 0? Secant of 0 is 1 over cosine of 0. And you know cosine of 0 to be equal to 1. So this is just equal to 1.